Hello again. This is one of the series of video tutorials on how to do paper chart plotting, basically, using electronic charting program, in this case qtVlm. And we're doing exercise to illustrate the process for our inland and coastal navigation course. We're using problems from our workbook 18465TR. And here's one that we're doing. This is now one that's going to be very quick. I mean, it just instantaneous answer you get with this, but we have to take a few minutes to explain it. This is a radar, apparently a radar bearing that was taken. You've got a range and bearing. Now, that could be two things. Here, does it say radar? Here it says radar, but you could get the range. Now, not in this particular case. You'd have to have a little peak or something, but you can measure the distance off. You can measure the distance off with a sextant, the vertical height of a sextant, or you can do you can get distance off various other ways, and then you can just take a compass and get a bearing. So, but range and bearing in this case is intended to be with a sextant. I mean, with a radar, and so this is the problem: is observation point is seen 3.4 miles off, nautical miles off, at a relative bearing of 066. Now, we have a couple things to do with the relative to understand what's going on with this problem, but once we understand what's going on, the plotting is seconds, literally. And so first of all is that we got a course here of 070 magnetic, and this is a 20 degrees east, so correcting at east as a 90 degrees true. So I can bring in this picture and show here's what is meant by relative bearing. The ship, the vessel is sailing 070, which is 90, and it observes this target at 66 degrees R, and the relative bearing are 0 to 360, measured to the right like this. So this bearing 66 over here would be 70 plus 66, that's 136 M, or 156 true, either one, depending on what units you're using. Now, if this bearing had been over here, straight up and down like this, over here, that would have been 270 R. 270 R straight up. Okay, so we're dealing with something that is bearing from the ship, from the vessel, 136 M, and it's a 3.4 nautical miles off. And I had made one other quick sketch just to show, if it's radar, what this might look like. So we're traveling along the coast, and then here is the range rings at 1 mile separation, 6 range rings, 1 mile separation, and here's kind of a real crude mock-up of what the radar image might look like, and here's this bump here, which would be the point, and that point is very steep, and so it's blocking everything behind it, so it would look something like this. And so this point then we measure with an electronic bearing line. We get this angle here is 66 degrees, and then we use a variable range marker to come out here and get that's 3.4. So that's the way you read that from a radar, and then we have to just come in here and plot it on the boat. I mean on the charting program. So that should be quick. So here is now, and our earlier videos show how you find things. If you don't know where observation point is, observatory point. Observatory point. You can just do Command F, search observatory point, and it'll bring you right here with this program. But let's do this. There's different ways to approach this, but let's just make a mark, any mark, and let me just call this observatory point, O-B-S-E-R-V-A-T-O, observatory point. And we know something about observatory point. We know that we were 3.4 nautical miles from it. So 3.4 goes in here. So I'll just put a range ring on there, and then I'll put this right on observatory point. So first of all, I know then that I'm somewhere on this line here. Right? I'm somewhere on this line headed this way on this circle. And so then what we would do is probably the easiest way is do a path. I could do this. I mean, I could do here and go ruler tool and then come out here. Oh, but that's wrong. It's backwards. I'd have to do some mathematics. I don't want to do that. So let's do a pathway. Let's create a pathway. This is actually problem number 4-15 in our workbook. So I'll just call it 4-15, and I'll append the POIs. And then, so I'll start here, and then I'll just go out. Start here. Well, doesn't matter. This really doesn't matter. But, in that case, it worked out just fine. See, what I was going to do is click here and then click here and reverse it. But since I clicked out here first and then here, then we've already got the right bearings here. What we want is, what was it? 136M. So 130... right there is 136. So our fix is right here. So we could do another thing. We could just drop a mark there and bring that right over to here like this. And then just put your mouse on here and you get, let me bring this over, see what the book says the answer is. And, I can't do it that way. Sorry. What is this? Okay. No, I'll just do it up here. I'm sure it's got to be the right answer. Okay, here we go. Let's see there, and I can read it that way. 48, 12.1. Oh no, I don't have the, okay, sorry. This is silly. Okay, there you go. I have to do it this way so everybody can see it. Okay, so here, this is, the answer here is 48, 12.1 and 123, 40.4. Now, the radar can be very accurate, but, for the ranges, it's very good for the ranges, but sometimes the bearings can be off. So another one of the exercises we'll do down the line here is 2 radar ranges. That's a more accurate fix than this one because we don't know what heading it is. When you're doing this, you're measuring 66 relative to what the compass is reading, but the boat heading swings around a little bit. So the fact that this throws off the precision a little bit, whereas if we just use 2 ranges, we can get real accurate. So that's the answer. That's the exercise with this one, and then we'll have related other problems shortly.